Okay, just as everyone's coming back in, up next we have Lesley Carhart talking through building your first operational technology incident response plan. Lesley Carhart is a technical director of incident response at the industrial cybersecurity company Dragos. And prior to joining there, she was an incident response team lead at Motorola Solutions, and she's also a SANS ICS 515 instructor. So if there's any pancakes in the audience, you should be afraid. Could I please get a big, massive round of applause for Lesley?
Oh my, I have to stand in front of I can't wander. So that last talk was one of my favorite talks on quantum computing ever. We've gone from removing the hype. We've gone from like AI and quantum to why quantum might not be so scary, and now we're going to talk about Windows NT. So I hope you're all looking forward to talking about really old computers. So sure, I would love a microphone. Thank you. Oh, a solution presents itself. Hi, everyone. I'm Lesley. It's very nice to meet you all. I work for a company called Dragos, where I do industrial cybersecurity. So I've been doing that for a very long time. Almost 20 years now, I've been working in the industrial space, doing incident response investigations and forensic investigations on things like power plants and industrial facilities, mining equipment, trains, aircraft. I got my start as an aircraft mechanic, doing aircraft maintenance on avionics computers. And that kind of brought my hacker mentality into this combination space of OT cybersecurity. So yeah, I've been doing it for a really long time now. I teach about it for the SANS Institute. I do a lot of education around that. I do mentoring, I do career clinics, I run a conference that's free online, and I do a lot of volunteering around TAFE and professional year programs. I'm also a new immigrant to Australia, so thank you very much for making me feel welcome. I'm very, very happy to be here. I live in Melbourne now, and it's surreal being back here after being here as a keynote 4 years ago and having no idea that I would be looking towards becoming an Australian citizen 4 years later. So so I'm here to talk about really old computers. We've gone full circle in this conference. We've gone from AI, ML, quantum computing to, oh my God, we have to talk about Configure and Windows 95 still. So let's talk about the problem first. Why do you want to be in this room? Who works in OT right now in this room? Raise your hand for me. Okay, so some of you are just maybe interested in OT and what's going on in industrial. All right, cool. Industrial technology is all around us. Industrial control systems, OT networks, devices that do kinetic, physical interaction with the world surround us all the time, and we don't think about a lot of them. And they're doing really important things for society. They're keeping the power on. They're making sure things we don't think about failing, like clean drinking water comes out of the pipes, that the trains and the trams keep running, that just-in-time logistics and transportation of goods and food still functions. So these devices are doing silent things all around us all the time, even in this building. They're doing things like keeping the air conditioners on, keeping the heat on when it gets chilly, making sure that the lights and the elevators and things like that function. Those are all industrial control systems. So they're doing really important things, and we don't think about them a lot, but we are perpetually surrounded by them. And these devices are becoming more and more like the computers that we are concerned with as cybersecurity people. They're becoming more computerized, more digitized, and more interconnected to stuff, which makes them vulnerable to cyber attacks. And that's why I do the job full-time, which I do every single day, which is responding to incidents in these process control networks. And there's not many of us. I was at a conference focused on OT cybersecurity a few months back in Singapore, and I was talking about this and how I do this weird job of responding to incidents in industrial spaces. And I was like, well, there's probably about 100 of us who do this in the world. And I looked out at the audience, and then I was like, well, 30 of them are in the audience right now. This doesn't seem great from like a disaster recovery perspective. We probably shouldn't all be in the same room at once. But it makes it really hard for me to hire people. Like it's a challenge that every business that has any industrial cyber-physical systems, from building automation systems, to logistics systems, to transportation, to manufacturing system has to deal with as these systems are changing. And there's like none of us. Everybody wants to learn about AI and quantum and things like that. And I'm like, we still got all these really important old computers that are doing really, really critical things for society, for civilization. And nobody wants to study that in university. And the university programs don't cover it. So I do these talks, and I try to get people interested in OT cybersecurity. And from the perspective of this talk, some of you might become responsible for some of these systems, and it's vital to learn how to secure them and how they're different. So I've got like 30 minutes to give you some basics. So first of all, things that you need to understand about why you need to care about these systems in your environment or environments that you're responsible for in the future. Number one, these devices in the 1980s and 1990s, digital control devices for these cyber-physical systems that I named a whole bunch of examples. It could be canning tuna to running trains. These industrial computers didn't used to be connected to anything. They used to be connected only to the things that they needed to interact with via like serial or simple electronic communications, simple circuits. But now, for efficiency reasons and for cost reasons, they're increasingly networked. They're increasingly connected via Ethernet, via the internet, via cloud, because it makes things faster and more efficient, and it costs less to support and maintain over long distances. So they are increasingly connected for remote access, for telemetry, and for large-scale, super-fast computer-driven operations. And we have this thing that we call IT-OT convergence, where again, because it's cheaper to like use Windows for control computers, like the interfaces that people use, the human-machine interfaces in these environments, than it is to build your own operating system for that. Of course, industrial manufacturers have started putting in familiar networking technologies like Cisco or Juniper, as well as a lot of Windows into the higher level human interfaces for these process control networks. And of course, those are vulnerable to commonly known typical cyber attacks and malware. And we also have this problem of homogenization. So these industrial vendors used to build like custom, bespoke industrial deployments for every customer, but that got really expensive and really complicated to support. So now when they roll out a deployment of industrial technology to tuna canning, or to building tires in a car manufacturing plant, they deploy the same equipment with the same IP addresses, cookie cutter, and then they customize it. So that, again, makes the attack base easier to access. That lowers that barrier to entry for adversaries because these industrial networks are similar. And obviously, when we're talking about these legacy serial protocols and things that we're now sending out over Ethernet, and we're connecting to the cloud, we're connecting to remote access, they weren't intended for that. They were not designed with that threat model in mind. So they are not secure protocols, they're not encrypted. The devices are very simple, very easy to exploit. And so we have to take that into account now that they're connected to everything. And they're very hard to change. It's not an issue of like people don't care or we don't know that they're vulnerable. But when you go out and you buy a power plant to keep for like 30 years, and it's been tested in a single configuration by the OEM for like 2 years in a lab to make sure it's safe and nobody dies. You can't just go switching out parts. You can't just replace operating systems because that could kill somebody. So the systems have to stay in production for a really long time. They're expected to. And they're expected to stay in a single configuration unless there's a long period of vendor testing and approval. And finally, these systems are doing so much of stuff that it's vital to society, to civilization. Again, we're surrounded by them all the time, and more of these systems are complex and digital. Things that used to be able to fail over to manual operations, they can't anymore. They can't do that anymore because they are so complex now that a human operator can't take over, and the people who used to do that job manually have all retired or died. And bad people know this. They know these are critical environments, and they know that they're vulnerable. So this is why I do this job full-time of incident response in OT, because there's people who have realized that for a number of reasons, these are good targets, they're good for extortion, they're good for geopolitical goals, and they are vulnerable to attack for all the reasons I just described. And to clarify that a little bit more, I respond to 3 general categories of incidents in these critical infrastructure industrial systems. The first one is insiders, usually unintentional insiders. People who just wanted to watch Netflix on the oil platform at night. When they're alone at the mine and their FIFO work or whatever, they want to contact their family or look at their photos, watch a movie. They plug something in, or they're doing shadow IT. But there are malicious insiders too. I've been escorted in by the military and police to sites. It gets really ugly sometimes. There's ransomware, there's commodity malware, and I mentioned there's more and more Windows-based systems, especially legacy Windows systems, that are super vulnerable in these environments. And they're not necessarily controlling the low-level process. They aren't the PLCs, but they're like the systems you use to make sure that the system is not going to kill somebody, so that's the operator interface. And when that goes away, you have to hit the big red stop button on the wall because you can't see if things are running safely anymore or control the process. So that can be very impactful, even though it's not necessarily impacting those low-level industrial devices. And finally, yes, states are still doing sabotage and espionage like they have since the beginning of human civilization. But now they've realized that they can do those things without sending James Bond across the planet. Now they can do that by accessing a computer across the world. So when they have the same geopolitical goals, along with things like conventional war that they had 100 years ago or 500 years ago, now they're using computers to conduct some of those activities when they want to. The thing that you really need to understand here, though, is that these cyber attacks have real-life consequences. This is not a domain controller being hacked. This is not 20 computers or 200 computers being infected with something. This is people dying. This is companies going out of business because they can't produce products anymore. These attacks have real-life consequences. The hackery stuff doesn't matter anymore. AI, quantum, whatever, cool stuff, EDR, the buzzwords go away. This is like a matter of, does somebody die or not? And that is the space I work in that I need more people in. So let's talk about some very simple basics for dealing. Again, I normally talk about this stuff in 5-day, 6-day courses for SANS, or 1-day workshops with companies. So I've got 20 minutes to cover some basics with you. You need to have a separate incident response plan for how to deal with cyber threats and cyber attacks in these industrial environments. And even if you don't know that you're responsible for some industrial OT networks, you probably are. If you work for a large organization, you have data centers. They have ILO, they have backup power systems. Whatever industry you work in, you will probably eventually be responsible for one of these networks. And you have to plan for incidents differently in these environments. You need to think about every phase of incident response differently in these environments. So I'm going to give you some tips for doing that. Doing this exercise of developing an incident response plan for your OT environments will help you understand your OT environments. I know they're scary, they're novel, they're weird. You don't know what these PLCs are or how they work. There's all these different protocols. This exercise will help you understand things and understand what's important to secure. And you're going to need a lot of interaction with the industrial staff to complete this plan, which also helps you. Because there can be a lot of hostility between the operational staff who have been audited to hell by cybersecurity people for the last 20 years and the cybersecurity team. This is a great exercise to rebuild that relationship and understand what they do and what they care about. These are the 5 key things you need to keep in mind while you are developing your incident response plan for OT networks. So the first one is safety comes first. Human life, human safety, the environment, etc. Those things come first. It's not, oh, they got on the domain controller and they exploited things with Bloodhound. And no, the question is how many people are going to die? Who is going to lose a limb? What's going to happen to operations? That's what's important. That's what comes first. And then followed by the continuity of business operations. Can you keep staying in business, not losing millions of dollars an hour with your production down? There are tolerances in all businesses. They oftentimes have very small margins for failure. When you're talking about like critical infrastructure and utilities, they can only be down for a certain number of hours without impacting society. When you're talking about manufacturing, there's a certain amount of time that you can be down and not produce your product before you fail as a business, and you need to understand that. There's a huge vendor landscape. So there's a bunch of vendors in play in this environment. Your OEMs who produce the industrial equipment are there. They are your support people. They make decisions about what they will and will not warranty as safe to operate. And you will need to work with them as part of your incident response operations. You need to know where they fit in, what they do, and what they will and will not permit you to do as an incident responder. And you're going to deal with really old stuff. And this is why I can't hire anybody. Because I see Windows NT and Windows 95 on like a monthly basis, and I have to do forensics on it, and nobody's learning that in university anymore. And it's really, really bad. I'm actually having more luck with TAFE right now because the universities are focusing on the AI, quantum stuff, and like TAFE is willing to like at least go back and look at old computers. So it's really scary for me right now. Like, if you want to do this stuff, you're going to have to get rid of your modern tool reliance on modern tools like EDR, XDR, things like that, and be able to do things old school like we did them in the 90s and the aughts with those tools that we used back then, because that is the era of equipment that's running a lot of society. And you'll also have to deal with the low-level devices, so the PLCs, the RTUs, and the protocols that they communicate in over the network, which are quite different than IT protocols. You don't need to know all of them. There's thousands. But in your industry, in your business space, you need to start understanding what exists and what they do. So to talk about how to develop your OT plan, your OT incident response plan, with all of these considerations, I'm going to talk through every phase of the SANS PCRL model. So this is a very common model for incident response. I use it because it's granular and people are familiar with it. It's been around for like 30 years now. And I'm going to go through every phase, and I'm going to talk about the distinctions. So I'm going to give you a cut sheet. You can take pictures of the things that will be different. I promise you they will be different in OT, and you need to plan for that. Again, I do incident response in OT as a full-time job. There are really incidents out there. They are really impacting people, and you need to have a plan. It's a when scenario, not an if scenario now. Adversaries know these are vulnerable networks, and they're doing important things in your business. So let's talk about this by phase, and let me talk about the distinctions, the things that are unique in OT. So first of all, the overall document. Really, really important, but with all the stakeholders, the different OT leadership, safety personnel, the vendors in play, you need to understand and document in your incident response plan for OT who owns the plan, and who is granting the incident response plan authority to make decisions and do things during an incident. Because I promise you will run into conflict with the OT personnel. They're going to be like, who are you? Are you auditors? What are you doing? We don't want you touching our stuff. So ownership of the plan and authority is really important, as well as strong revision control. Things do change in these OT environments. Vendors do major updates. There's new staff, there's new procedures, there's new production, you acquire new facilities, and this plan needs to be routinely updated and updated on triggers, like acquiring a new business, a new facility. You need to have a mutual glossary of definitions because the acronyms in your industrial environment are not the same as the acronyms that your cybersecurity team uses. And terms like incident will mean very different things to your safety staff than to you as a cybersecurity person. So you need to have a clear shared glossary so everybody understands what's being referred to during an emergency. You need to know what the parent documents are, like your enterprise incident response plan and your OT business continuity plans, and how those tie into the documents and where to find them. You need to make sure your document isn't too long to read and also not too short to be useful in an incident. So that means drilling, exercising your plan, making sure it works. You need to make sure everybody knows where it is. It needs to be in a central location, and the OT stakeholders and the cybersecurity stakeholders need to know how to find it and which version is most current. And you need to have a complete plan that's useful during an emergency, so you need to test that out. But also, it can't be overly prescriptive because, again, people might die. You need to be flexible. You need to understand that these are unpredictable incidents. They are not just the same ransomware incident over and over like we see in enterprise. So in these cases, we need to have a little flexibility to make on-the-fly decisions to adapt for like life safety conditions and the weirdness that comes along with dealing with like Slackware Linux and Windows NT and DOS. So yeah, we need to have a plan for that. So let's get to the life cycle. So preparation, what's different? Here are some questions to ask yourself about your plan. You can go home, this is your homework. If you might be responsible for an OT environment, or you might be responsible for an OT environment in the future, you should ask yourself these questions about your incident response plan. So first of all, are our staff comfortable with dealing with the OT team, or do you hate each other? I oftentimes have to like do food bribery, like buy people beers to get them to talk to one another. So you need to understand, do you know who those people are? Do you have a relationship where you can talk to them? Is it respectful? Secondly, are your personnel adequately trained on OT technologies? Do they have the understanding of these legacy, weird OT devices that they need to be successful during an incident? Again, these systems look nothing like your enterprise systems. Do they spend time shadowing in the industrial environment? Do they understand how things work? Do they know how to deal with legacy computers? Do we mandate exercises and drills that include and focus on the OT environment? Again, this is a great relationship builder and a great way to test your plan actually works for OT. You should have this mandated at least once a year, have a tabletop exercise with OT. And if you have technical procedures like containment, like forensics, you should be drilling them routinely during safe windows. Have you checked that you have an asset inventory for OT? You probably don't. And a network map. Yeah, so both of those documents, you can't just have faith in them. You have to actually go validate they're current and up to date, and they actually work for incident response, because I promise you, they're out of date. Let's move to identification. So this one's a tough one. Identification includes like detecting an incident, escalating the incident, and doing forensics to understand what's actually happened. So first of all, your logging and monitoring technologies for enterprise will not adequately cover OT because of the age of the systems and the vendor constraints and the weird low-level devices. So do you have adequate logging and monitoring to understand what's going on in your OT environment? Do you know where your logs live? Do you know where your DNS logs, your DHCP logs are? And what's the retention of them? You should probably build some kind of spreadsheet, like a collection management spreadsheet, to understand that in OT, so you have it in an emergency. Do we understand the context of alerts coming out of the OT environment? Again, this is a human relationship thing and having somebody to call. But like, alerts without context are just noise. That's alert fatigue. You have to understand the context of the alerts and what actually is meaningful from a baseline perspective, and that's something you have to develop over time. So that's a projectized thing that requires human relationships. Does the plant know how to contact us, and will they contact us if there's something weird? That's a really good question. Detection here is twofold. Yeah, you have your monitoring stuff, but it's not adequate to catch like advanced threat actors abusing administrative credentials, living off the land stuff. Weird process tampering is detected by operators looking at things and saying, hey, that's weird, and I don't know why it's happening. So they're a wonderful detection mechanism. Do they know how to contact you and tell you that something is weird and they can't figure it out? Do you tune your severity matrix for severity 1, critical incidents, severity 2, etc., towards like, is somebody dying? Or is it just like, oh, 40 computers are infected, 400 computers are infected? Yeah, we don't care about that. I go into environments where every single computer is infected with Configure, and we're not going to touch it because they're in operation, and touching it might kill somebody. So focus on life safety, focus on operations, business continuity in your severity matrix for OT incidents. Really crucial. Does our escalation and communication plan include the OT people, the stakeholders, the facility managers, the people we need information from to understand the context of alerts? And the reality of these environments is usually the industrial people will come in and do a bunch of troubleshooting, a bunch of swapping out devices to figure out whether something's just a maintenance error or a human error. And that's what it usually is. 99.999% of the time, things that fail in industrial environments are not a hacker. So yeah, their logical train of thought is, let's do some troubleshooting and see, hey, did something fail? Did something break? And doing that will will destroy a bunch of your forensic evidence. That's going to be the evidence you need to do cybersecurity investigations. If they wipe the computers, they send them back to the vendor, they throw them away. So do you have a plan? Have you talked to them about preserving things you might want for forensics later on? And when do they call you in to collect that and save it? Or is it all going to be gone? Do you have a way to scope the spread of an incident across your industrial networks? That's really important too. Like, again, you don't have EDR across all these computers. I promise you, your XDR is not there. Your enterprise network monitoring and detection tools will not understand the industrial protocols or what they mean. So do you have a way to understand how far an adversary has gotten in this environment and what that means for the industrial network? And you need to know all the different stakeholders and players that are going to be involved in OT incident response. That could be like SOCI, like regulators, needing to be informed that there's an incident happening, but it could also be like partners from a threat intelligence perspective, from an incident response perspective, and it will certainly include the industrial vendors. Sometimes they're the only ones who will allow their team to do forensics on one of their systems. So you might have to contact them to get logs or forensic evidence, and you need to understand that in advance. Containment. Containment is where these plans usually fall flat. When I do real incident response, when I do tabletops with customers, containment is the paralysis point. This is so hard in industrial networks. So first of all, do you have a playbook to do containment in industrial networks? This is really important. This is not like containment in your enterprise network. You do not have EDR on every system. You cannot hit a magic button to shut off the computer, especially if it's running Windows 95. You need to know what cable gets pulled out of the switch, or which one they take an axe to if there's a really bad incident and you need to cut the fiber. So you need to figure out how you're going to isolate and contain these critical infrastructure environments. And nobody wants to make that choice because it's impactful to the industrial process. I talked about everybody wants remote access now, everybody wants telemetry, remote control of facilities across a large landscape. Containment is really impactful. It's an important cybersecurity defensive mechanism, but you need to know who makes that decision. You need to give them tools to feel safe and secure in their employment making that decision. And you need to understand exactly what that impact will be, not just on the process and operations, but on like your ability to do forensics and get logs, so incident response, recovery, et cetera. That all needs to be figured out in advance for your industrial facilities. And you need to test that and make sure it actually works. That's something you have to go assure the functionality of in advance. And finally, if you're going to cut off like your phones by yanking the cable out of the wall, cutting off the entire building, how are you going to contact one another? How are you going to do Teams calls? Is your access to your incident response plan document on SharePoint still going to work? So understand how you're going to get access to all the tools and the information and the backups that you need during incident response if you cut off the facility. This is something to work out in advance. Nobody wants to make this decision. So eradication is a stage of incident response that's oftentimes really forgotten in enterprise today. And again, like these skill sets are diverging. Incident response in OT is becoming very different than enterprise incident response. There are systems we simply cannot replace in industrial environments. The person who built them is dead. They are running Windows NT and you can't take it away. They have not figured out how to do that. That's going to be a multi-million project. So you have to be able to remove adversary changes to infrastructure, to industrial devices, to Windows computers, to Linux computers. And so there's things like Active Directory certainly present in these environments, and you need to know in that environment, do they have the competency and the ability to do the recovery things that you'd expect in enterprise? Can they do that at scale, like large-scale password resets? And I'll tell you, they are not going to be able to change all the passwords. Industrial devices oftentimes have hard-coded passwords in them, physically hard-coded devices. So you can't change the passwords. You have to figure out another cybersecurity mitigation. And you need to understand what accounts, if they're stolen, cannot ever be reset. And you need to understand, because again, these devices might not be able to be shut down or taken out of operations, who will revert changes to infrastructure, network infrastructure, Windows and Linux computers, the PLCs, and the remote access appliances. Who will do that in OT? Do they have a baseline and configuration backups to be able to do that? And can you do all the stuff that you expect to do during eradication and removing adversary logic, malware, et cetera, that you'd expect to be able to do with your modern tools in enterprise in these legacy, low-level industrial devices? Let's move to recovery. So first of all, here's a really good question. Do you know enough about your OT environments to know how long they can be down? I see this a lot. I see a lot of people who are not capable of telling me how long they can be down. And I'm like, you're responsible for cybersecurity for this really critical thing. How do you not know that? Again, that's a relationship, a human relationship thing. Do you know what they'll do before they call you in? Again, they're probably going to do a lot of troubleshooting and attempting recovery before they actually call you. So what does that look like? How will it impact your incident response and your forensics? Backups are crucial. The backups are probably not the same backup server as your enterprise environment, and some of them probably live on like USB drives in people's desks, or DVDs, or floppy disks. You need to understand that for your infrastructure, for your virtualization, for Windows, for Linux, and for your low-level devices. How are you going to validate and repair configurations of industrial devices? Does anybody have backups that aren't on the local compromised network? Questions to answer in advance. And do you have contingencies to do your recovery actions in these environments at scale? The maintenance people are used to replacing one device, not 10, not 100. That's not a normal maintenance thing, but an adversary will break everything. It's a completely different shift in thinking for them. Finally, lessons learned. So what do you do after action? Looks pretty similar to the rest of your lessons learned processes in enterprise. But you do need to involve different people. So you need to understand who's responsible for scheduling those meetings. You need to understand who needs to be present for them. You need to understand the timelines and expectations for generating reports, for storing evidence, for making sure that things are logged for the future. And you need to understand who needs to be a stakeholder from an OT perspective. The facility manager, the safety manager, who plays a part in making incident response decisions and writing this plan. And finally, how can you improve your cybersecurity in the future? That needs to be asked, and somebody needs to be responsible for making those decisions. So in conclusion, treat OT as a separate practice and plan. Make sure that you involve and build relationships with the OT staff. Do adequate shadowing, relationship building, food bribery, whatever it takes to rebuild those relationships. Go through phase by phase, like I talked about here in incident response, and consider how things are going to be different when you do them in OT and what's different and what matters. And test everything. Do not make assumptions. Do not trust without verifying. Make sure that you have up-to-date documentation and your plans work. It has been my absolute pleasure to talk to you today. I know it's a dry topic talking about like Windows 95 and older computers and non-AI things, non-EDR things, but this is really important. My contact information is here. I don't know if we've got a few questions that we have time for before we go to lunch, but I'm happy to take them. Otherwise, my contact information is on here. I have a blog, I have a LinkedIn, I'm on terminally online on social media, and I'm happy to talk to you. So please reach out. And I don't know, again, if we've got time for a question or two, but I know people want to go to lunch, and I'm keeping you for eating, so.
Thank you. I think we could squeeze in just one or two questions. I don't have any questions in through the app. Does anyone have any questions they want to ask? Yep.
I love Windows 95. With your incident response plan, it's very, I mean, I'm not from OT, but
Yeah, that's cool.
we've sort of built use cases to help that, right? Because we set up incident. How does that work with OT? Because I'm thinking how complex it would be to have so many use cases and so many playbooks. I'll give you an example, right? Third-party risk. You know, one of the third parties gets compromised. How do you handle that? And do you have incident response teams to make those decisions? Say, for example, legal, things like that.
So like third-party risk, like supply chain is a huge threat to OT because everything's got remote access now. Like every vendor has required remote telemetry, remote access to their OT equipment. So you probably have 8 or 9 remote access methods breaking your DMZ into OT at this point. And yeah, I mean, that is something you need a playbook for. That's a really good one. Ransomware is an important one. It's just such a pervasive threat. Really impacts those older Windows systems. Third-party risk, supply chain compromise. That's another great tabletop and scenario for a playbook. Yeah, you have to have some flexibility, but those attack paths are something you can model out with your engineers. That's something, the relationship building I talked about, like the building friendships, buying them beer, bring them pastries, like that's a conversation to have around a table. Like, what are you worried about? What's your worst day ever? And let's talk through what could cause that. They know how to break their systems. Just buy them a few beers. They'll tell you how they break things really bad. So, yeah, great question.
Yep,
Maybe one more? I know everybody wants to go to lunch. I won't be offended if you go run, get in line for food.
Hey, Lesley.
Hey!
A lot of OT environments, particularly in critical infrastructure, have pretty good muscle memory around crisis management because they're dealing with storms and physical crisis. How do you think they need to adapt to cyber?
Yeah, so you as a cybersecurity person, and this, not to you, you know this, but to everybody in the room, you need to use the stuff they've already built from a business continuity perspective. I already talked about that, like integrating your business continuity documentation, understanding how long things can be down. They've already figured that out. You just need to learn it. But from their perspective, they're used to like 1 or 2 things failing at a certain failure rate. Like things fail because humans make mistakes. The safety systems, the redundancy, the resilience is all built around like a statistical level of failures. An adversary is going to come in, they're going to break everything. And there's no contingency for that usually, unless it's like, what do we do if there's a hurricane that obliterates the building? Like, that's the kind of plan that you're looking at for there. So recovering from a massive, purposeful, malicious attack is very different than the things they planned for in the past. And you both need to adapt accordingly. I think that's all we've got time for. Everybody needs to go to lunch. Thank you for letting me be here.
Much for
I'll be
coming
around.
along.
Ask me questions. Reach out.
Thank you.